Hello everyone, we are starting with the 16th lecture of Algebra, and now our focus is on more sketches. Now let's look at what we have done so far. Graphs of functions, construct table of values and draw, recognize and interpret graphs for functions of the following form. Ax power n includes sum of no more than 3 of these. That means ax power n could be ax square, could be ax cube, something like this. So we have done things like that. And then we have ab power x plus c, where n could be -2, -1, -half, 0, half, 1, 2, 3. A and c are rational numbers, b is a positive integer. So now it could be something like this. It could be a cubic, it could be a linear part, and then a reciprocal part, and things like that. This we have done. And now we have to focus on these sketches. I'll come to that in a short while. Solve associated equations graphically, including finding and interpreting roots by graphical methods. This we have done. We have drawn a line, we have drawn a curve, we have found the point of intersection, that is the roots of that single equation. Draw and interpret graph representing exponential growth and decay. This is not yet done. And estimate gradient of curves by drawing tangents. This is done. Sketching curves. We have done linear, quadratic, cubic, reciprocal, exponential, but we have to do a little bit more. This one, ax plus by is equals to c. This is linear. This is done. This is quadratic. This is done. This is cubic, but it's not completely done. So this is our focus of today. Cubic with a constant over here. And this one is a cubic, which can further be written as y is equals to x common ax square plus bx plus c. And we are focusing on these cubic and the sketching curves. And then it says m and n are integers and functions will be equivalent to. So now there are some more. Y is equals to m over x plus n. We have drawn y is equals to m over x, the simple reciprocal like this, and then reflection in x-axis. We have done this thing. And y is equals to mx, m power x plus n. Y is equals to a power x, where a is a positive constant. That is a power graph. We have done things like that. Not like this. Something like this. So we have drawn this, but again, this would be new over here. So this thing we have to do, this thing we have to do. So that is our focus right over here. And then what exactly will we be focusing on? Knowledge of turning points, vertical and horizontal asymptotes, A, S, Y, M, P, T, O, T, E, S. This is what we'll be focusing on. Roots, and then symmetry, wherever that's possible, whether this is line symmetry, it could be rotational symmetry. So we'll be focusing on these things. Find turning points of quadratics by completing square method. This is not yet done. So now in today's lecture, let's get started with this idea. Let me first get started. Let me add a page over here. And the very first thing that I want to focus on is this thing. That is quadratic equation and the 3 different formats. So let me focus on all 3 different formats. The first format that we focus on, that is y is equals to ax square plus bx plus c. This is called the general form of a quadratic equation. What is the usage of this? So the usage of this form, it's in this thing called the quadratic formula. We use it in the quadratic formula. How we use it? We use it to find the roots of equation. Roots of equation means solution of equation. It's also known as x-intercepts, where the graph cuts x-axis. And we know how to use the quadratic formula. X is equals to negative b plus minus square root. The whole square root contains b square minus 4ac. The whole thing is divided by 2a. So that is the first application of the quadratic formula. So that is one application. So this is one part A. Now, if I focus on the second application, that could be in terms of a sketch. We know that y is equals to kx square. Y is equals to negative kx square. And if I draw a small grid over here, so just let me plug in this thing over here. And the same thing, let me copy it, let me paste it over here. So now if I want to draw y is equals to kx square, that goes like this. And let me just shift it down a bit. So this is y is equals to kx square. Similarly, let me draw the same thing upside down. That is like this. So now over here, what is the difference? The difference is the negative sign. Because of this negative sign, the graph is reflected in x-axis. So this is reflected or reflection in x-axis. If it's y is equals to kx square, the turning point TP stands for turning point. So that is TP. This is 0, 0. This is 0, 0. TP stands for turning point where the graph turns. It's also known as the vertex. So that's where the graph turns around. This is a happy phase graph. So this is happy phase graph. This is a sad phase graph. That's how the graph is. Now let me add something more to it. So what if I want to draw something like this? Let's say I want to draw y is equals to x square plus 1. So now the original graph, which is over here, let me just copy this. And it's pasted over here. And I want to increase it, shift it, translate it up by 1 unit. So let me draw this green one. That is the translation one. Actually, let me simply copy this. And it's already copied. And let me copy and change the color to green. And now copy. And now this thing goes up like this. So what is happening is that the 0, 0, the turning point becomes 0, 1. So the 0, 0 becomes 0, 1. So the graph is translated up by 1 unit. That is what is happening over here. Similarly, if I draw the graph y is equals to x square minus 1. So again, let me copy this red graph. Let me paste it over here. And now I want to draw minus 1. So something like this. It's not drawn to scale. And let me change the color to purple like this. So this is y is equals to x square minus 1. This is 0, negative 1. The turning point and hence all the points on the graph, they are translated down by 1 unit. When we will study vectors, we will write this thing as a column vector. We will write this thing as 0, 1, no horizontal movement, 1 unit up. And this will be written as 0 and 1. Last time we talked about 2x square and 3x square and the flattening and this thing that is already discussed. If you want to, let me just write it over here so that everything falls into one place. Actually, before that, let me, no, not this thing, and this thing over here. Let's say I want to draw y is equals to x square, negative x square plus 1. And this is y is equals to negative x square, negative 2. This is just a rough graph. So let me go over here. The blue one, copy it, shift it over here, all good, and paste it over here, all good. And then let me choose the same thing. This is plus 1 that goes like this. This is minus 1 that goes like this. And let me just change the color. This is purple. And this thing goes like this. Okay, so this is green like this. So the green one is y is equals to negative x square plus negative x square is this thing, the green one. And this one is y is equals to negative x square plus 1. Let me just swap the colors. So this color is green. Actually, this is blue. And this is green. Okay. Now over here, this blue one is the right one. Y is equals to negative x square. And this purple one is y is equals to negative x square, negative 2. This is 0, 0. This is 0, negative 2. This is 0, 0. And this is 0, 1. So that's how these 4 graphs are drawn. I'll just pause the recording for Azan. So now let's resume. Let me focus on the graph. Y is equals to 2x square. So let me choose the graph from here. This is y is equals to x square. That's the red one. Let me make the graph more steeper. Let me choose green color. And something like this. Not very exact, it's a sketch. So now y is equals to x square is the red one. For a second. Y is equals to x square is the red one. Y is equals to 2x square, that is the green one. And that's how they are drawn. That means if I say y is equals to kx square, if k is greater than 1, the graph gets more steeper towards y-axis. And the logic was explained earlier on. Now over here, let me again draw the graph of y is equals to x square. That is the red one. So let me write over here, red color, y is equals to x square. And in purple color, I want to draw y is equals to half x square. Now let me draw half x square. Something like this. Maybe a little bit more, less exaggerated. So now let me just shift it properly. Something like this. Uh, no, I'm not satisfied with it. Let me draw it again. Okay, I think this is better. So the purple one is y is equals to half x square if it's of the form y is equals to kx square. Black color, y is equals to kx square, and if k lies between 0 and 1, the graph gets more flatter towards x-axis. Now let's say if I combine these things, y is equals to 2x square minus 1. So 2x square is more steeper. So let me choose this thing and let me draw it over here. That is 2x square. And minus 1, let me shift it down by 1 unit. Something like this. So this is 0, 0. So this is 0, 0, the vertex, and this is 0, negative 1. It is shifted down by 1 unit. So let me change the color over here. This is y is equals to this 2x square minus 1. So this is y is equals to 2x square minus 1. Let me just shift it. Change the color, that's right over here. Something like y is equals to negative 2x square. Now let me choose this thing. I think it's already chosen. That is the green one. Let me just shift it all the way up. Did you see what I've done? I have flipped it around. And now this green one is y is equals to negative 2x square. So two things have happened over here. The first one, that is steeper towards y-axis, and at the same time, because of the negative sign, this is reflection in x-axis. So that is the basic idea that we need over here. The second thing in quadratics, that is called the completed square method. The format looks something like this. Y is equals to ax minus h whole square plus k. What is a? A is the coefficient of x square. If a is positive versus a is negative, if a is positive, what happens to the shape of the graph? So let me choose the same color as before. Let me convert everything to purple color like this. If a is positive, the graph has a shape like this. If a is negative, the graph has a shape like this. Very simple. What about h and k? H comma k, this is the coordinates of turning point TP or coordinates of the vertex. Now there are two things over here that we need to take care of. That is, in completed square form, there are two things that needs to be taken care of. Part A, that is the sketch itself, and then part B, that is the conversion from the general form to the completed square form. We have to learn how to do the conversion. Now any one of them could be the first part. So let me get started with part B first, or let me just change the order. So this looks better. So let me just shift this thing down, shift this thing like this. Doesn't make a difference which one you learn first. So first thing, second thing, this is part A, this is part B. So the conversion. So if I talk about the conversion, there are some pointers that you need to listen to. And let me grab my phone. Let me also add voice notes to it so that you can also listen to it soon. Now, first of all, the rule is make sure the coefficient of x square is 1. If it's not 1, take common. The next voice note. First add, then subtract square of half the coefficient of x. But before that, you need to rearrange in such a manner that you have the x square term, the x term, and then constant on the very side. Then in between, you will first add, then subtract square of half the coefficient of x, and then you would rewrite it in the completed square form, and then you would simplify. Now, watch what I'm going to do over here. So now we have y is equals to x square plus 4x plus 10. This is the x square term, this is the x term, this is the constant term. What we will do is that we will write x square and 4x first, constant term on the side. We will first add, then subtract square of half the coefficient of x. What is the coefficient of x? Coefficient of x is 4, half of that is 2, and 2 over here. Now look at the working. What am I trying to do? What I'm trying to do is that I need to get this thing in the form a plus b whole square or a minus b whole square. That's called the completed square form. So now the logic over here is I need to get all the x consolidated inside a bracket. Now when I do this, what happens? Think about it. I'll take the x from here. I'll take the 2 from here. I'll take the plus from here. This is x plus 2 whole square, which is x square plus 2x plus 2x plus 4, which is x square plus 4x plus 4. So this is grabbed, consolidated inside a bracket. So that is what is happening over here. So now I'll write x plus 2 whole square. This is known as the completed square form. And now what are we left with? We are left with this minus. We are left with this minus and then 2 square and then 10. So 10 minus 4 is 6. So that's a plus 6 over here. And is it of this form? The answer is yes. So we have y is equals to a x minus h whole square plus k. There is this y over here. Compare coefficient. Y in place of y. In place of a we have nothing. That means it's 1. X plus 2 is x minus h. Minus h is plus 2. Therefore h is negative 2. A is positive 1. K is 6. If a is positive, that means the shape of the graph goes like this. And minus 2 comma 6, that's the coordinate of the turning point. So we are interested in two things. We are interested in the shape. We are interested in the vertex or the turning point, and we will sketch the graph. So let me just add a grid over here. And let me mark the point negative 2 comma 6. So let's say this is negative 2, this is positive 6. That's the point over here. And the shape is like this. So let me draw the shape like this. And let me grab this thing, place it over here. And that's how the graph is drawn. That is the lowest point through which the curve is passing. And that's how a sketch is made. Now it's time for you to go over it and understand what I have done. I have made sure the coefficient of x square is 1. Then the x term, then the constant. The constant is pushed all the way to the side like this. After these two, first add, then subtract, because you're adding a 0. What? Square of half the coefficient of x. I'm skipping the logic. I'm not explaining the logic over here. That could be for some other video. Rewrite these first three terms as a perfect square. This is the expansion of a plus b whole square. So this is a square, so I'll write x over here. This is b square, I'll write 2 over here. And this middle term is positive, therefore there is a positive sign. Simplify, simplify, and that's how you get it. Then you compare coefficient, then you sketch the graph. That's how this thing is done. So we are doing two things at once. The first thing is the conversion. The second thing is the sketch. So let me also write over here, the sketch was also done in the same thing. I could have waited for later, but I just did it over here. Now let's again move to these two things. The first one, the second one. First one, second one. Y is equals to x square minus 8x plus 2. Y is equals to x square minus 8x plus bracket square minus bracket square plus 2. What goes inside the graph? The coefficient of x, half of negative 8 is negative 4, negative 4. That's all you have to do. Rewrite the first three terms as a perfect square. So take this, take this. Since the middle sign is negative, therefore this is x minus 4 whole square. And then over here negative 16 plus 2. Y is equals to x minus 4 whole square minus 14, and that is the completed square form. Now let me check my messages. If this is all good, all clear. Now let me just write the format underneath it. So this is a, y is equals to a x minus h whole square plus k, and this is a is positive. Why? Because there is a 1 over here, and I can also see that the coefficient of x square was 1. I could have picked it up from there. Minus h is minus 4, therefore h is 4, therefore k is negative 14. So 4 comma negative 14, that is the turning point, and a is positive. The shape of the graph goes like this. So now let me write it over here, and let me draw the graph. 4 minus 14. So this is 4 somewhere over here, and let me just push this grid down, and negative 14. So this is 4 and this is negative 14. That is the point, and the shape of the graph that goes like this. Let's place it over here, and that is how the graph is drawn. We are not interested in the x-intercept. If they will ask for it, we will find it. As such, they are not asking, we are not finding it. Now let's move to the next thing. Let me do one more example of this. Actually, two more examples. Y is equals to minus x square plus 6x plus 10. Now the coefficient of x square should be 1. So minus 1 should be taken common out. Y is equals to negative 1. This is x square, negative 6x, negative 10. This is negative 1 as it is, x square, negative 6x plus bracket square minus bracket square minus 10. So therefore negative 6, half of negative 6 is negative 3 and a negative 3. And then rewrite the first three terms as a perfect square, which is x minus 3 whole square, minus 9 minus 10. This is negative 1 x minus 3 whole square minus 19. Open it up with a negative 1. It multiplies over here. It multiplies over here. Therefore, this is negative x minus 3 whole square plus 19. Now compare coefficient with y is equals to a x minus h whole square plus k. This time a is negative. A is negative 1. So therefore, the shape of the graph is upside down like this. And then what do we have over here? We have minus h is minus 3, h is 3, k is 19. So 3 comma 19, that's the coordinate of the turning point. We have the shape and we have the turning point. So 3 comma 19, that goes like this. This is 3, this is 19. It's upside down. So let me draw it in blue color. It's upside down. Let me take this thing right over here. Let me mark this thing. That is the turning point. That is X, that is Y, and that's how the graph is drawn. All good, all clear? I'll just give you some questions to try. And one more thing. And that will end the lecture from my side, and then you will keep on trying so I can close the recording then and there. So that one is y is equals to 2 x square plus 8x plus 20. Now take 2 common out. So this is 2 common. This is x square plus 4x plus 10. 2 still remains on the outside. This is x square plus 4x plus bracket square minus bracket square plus 10. What goes inside the bracket? Half the coefficient of x, which is 2. Rewrite these three as a perfect square. This is x plus 2 whole square. The black bracket is there on the outside. And then this is minus 4 plus 10. So this is 2. This is x plus 2 whole square plus 6. This 2 will multiply with both of them. So therefore this is 2x plus 2 whole square plus 12. This is y. Now one more thing that I want to emphasize over here. That the value of a does not make the difference. It's the sign that makes the difference. So over here, if I compare y is equals to a x minus h whole square plus k, the value of a is positive 2. It's the positive that makes a difference. So the shape is like this. Minus h is plus 2, h is negative 2, k is positive 12, negative 2 comma 12. That's the coordinate of the turning point. And over here, let me just draw the grid and let me mark the point negative 2 comma 12. So this is negative 2, this is 12 over here. That's the point. And now this is going like this. So let me just draw the graph like this, a red color graph. Okay, so let me just put it over here and let me mark this point. So therefore minus 2 comma 12, that's the coordinate of the turning point. And one more thing that I want to emphasize, that is that when we talk about this thing, a line x is equals to h. This is the line of symmetry. That means the vertical line through x coordinate of TP, turning point, is this line of symmetry. Over here, x is equals to minus 2. So let me focus on this. So let me draw this line like this. It's a little bit messed out. So therefore x is equals to minus 2. That's the line of symmetry. Over here, x is equals to 4. That's the line of symmetry. Over here, this minus 3 is a bit shifted. Let me just erase this thing. Let me use this color. This is positive 3. This is 3, not minus 3. This is 3. And over here, x is equals to 3 is the line of symmetry. Over here, x is equals to -2 is the line of symmetry. So that completes this lecture, lecture number 16. So the focus of this lecture was quadratics. And in quadratics, we focused on the basic sketch and the completed square method. Actually, let me just take this time and let me focus on the factorized form also, because this is sometimes very, very useful. So let's not finish the lecture. Let's just move to this one and let me add 2 more pages over here. So the third thing that we are focusing on in quadratics, maybe I was in a hurry, and the third thing in sketch, this is called the factorized form of quadratic equation. Y is equals to a, x minus p, x minus q. They are in the factorized form. And what is happening over here? We know that this a is still the same. If a is positive, that's the shape. If a is negative, that's the shape. What about p? What about q? This minus is part of the formula. P and q, they are the roots of equation. And basically what we do is that we equate each bracket to 0. So that is the logic that we will apply. Now let me just get started with this. First of all, I need factorized form. Y is equals to x minus 2, x minus 5. This is the first worked example. First of all, when there is nothing on the outside, there is 1. This x is positive, this x is positive. Coefficient of x square is positive. Therefore, this is the shape. So don't just look on the outside. Also make sure that x is positive, the product is positive. And then when I make each bracket equals to 0, x minus 2, x minus 5 equals to 0. That means y is equals to 0 is the x-axis. So therefore, x is equals to 2, x is equals to 5. These are the roots of the equation. So let me just add the grid over here. And let me just shift this thing a little bit to the side. And let me draw a curve, something like this. Let me trim it a bit from here, and let me mark the points. This is one root, this is the other root, this is 2, this is 5. So based upon the shape, based upon the roots, we drew this sketch. This is y-axis, this is x-axis. As simple as this. Let me draw another one, another example. Y is equals to x square minus 4x. I can write this thing as x bracket x minus 4. I can write this thing x as x minus 0, x minus 4. Now, the coefficient of x square is positive. Therefore, that's the shape. And y is equals to 0 will give me the roots. So therefore, x and x minus 4 equals to 0. Therefore, x is 0, x is 4. Let me draw this thing again over here. Let me draw the sketch something like this. Let me take it and place it like this. And over here, this is 0, this is 4, and the shape is the correct one. Another graph, something like y is equals to x square minus 5x plus 6. Factorize x square minus 2x minus 3x plus 6. Double check, no harm. 1 into 6 is 6, minus 2 into minus 3 is minus 5, add up, minus 2 into minus 3 is plus 6, that's all good. This is x minus 2, minus 3, x minus 2, so this is x minus 2, x minus 3. Again, coefficient of x square is positive, coefficient of x square is positive, that's the shape, and the roots of the equation, x is equals to 2, x is equals to 3. How do you get the roots? Y is equals to 0. Again, the grid that's right over here. And let me just draw this graph. So that goes like this. I can trim a bit, it's a bit crooked. Okay, so let me just push this thing down a bit. And over here, this is 2, this is 3. That's how the graph is drawn. And one more example. Y is equals to something like 4 minus x square. Now this can be drawn in two ways. Method 1. I can write this thing as y is equals to negative x square plus 4. Second one, method 2. I can factorize it. This is 2 square minus x square. This is 2 plus x, 2 minus x. So now if I apply this knowledge, let me just put it right over here. Let me put this thing right over here. No, not this one. Okay. So now over here, let me draw negative x square. So it's upside down like this. And let me just push this thing up like this. And then let me copy this. Let me paste it. And let me change its color. So now this has been moved up by 4 units. So this was 0, 0, upside down. That's no space writing over here. And this is 0, 4. So this is vertical translation up. Over here, what is the knowledge? The knowledge is this x is positive. This x is negative. Coefficient of x square is negative, therefore this is upside down. And what about the roots of the equation? So let me just shift it over here. What about the roots of the equation? Y is equals to 0, 2 plus x is equals to 0, x is negative 2. 2 minus x equals to 0, therefore x is positive 2. So the roots are negative 2, positive 2. Let me draw it upside down. A better one. Okay. So now this is negative 2. This is positive 2. And this we have drawn it through the factorized form. This was drawn through the general form and then translation. 4 units up, vertically up. So that's how this thing is done. So basically now I can comfortably end my lecture, lecture 16, quadratics, general form, completed square form, factorized form, all the 3 forms. Based upon these, we have done a lot of sketches and now it's done and dusted. Till the next class, take care.